Hey guys, so here we have a box is being pushed at a constant speed, and I went ahead and underlined this because this is very important. A constant speed means the acceleration is zero, and that means that the net force is equal to zero. In both the y, or the perpendicular if you want to call it that, and the x, or the parallel if you want to call it that, directions. So the person exerts a force parallel to the plane, which means that they are pushing this way. You could call that force applied or the push or whatever. The mass of the box is 50 kilograms and the coefficient mu sub k between the box and the plane is 0.3. So both of those things are going to be important later. First thing they want us to do here is draw a free body diagram like this. So here we go. Well, here's the plane. So of course we are going to have some gravity downwards, so I will add that. Gravity always acts straight down. So I'm going to draw it straight down like that. So force of gravity down like that. And notice they say no components, so don't draw the FG parallel and the FGY of the force of gravity there. We are going to have the normal up. Now they don't have a grid here, but I know the normal up cannot be as much as gravity down. Why? Because we know a component of gravity matches the normal. So gravity's got to be bigger. So I drew this one 5 centimeters long and this one 4 centimeters long. We are going to have, because he is pushing up the plane, friction is going to be back down the plane like this. So friction back this way. So I'll call that the force of friction there. And then there is going to be a push up the plane. So, and let me draw this one like this. I don't know if that one's showing up there. That one's not really showing up. Let's use a different color there. Of course, yellow won't show up. All right, and we'll call this one the force of the push there. So that's all you want to do on this one. You don't want to draw the components of gravity. You never do. They explicitly told you not to do that. But in order to solve the problem, I am actually going to draw them on here. They tell you if you need to draw another triangle, do it somewhere else. But we already have this nice triangle here, so I'm going to sort of break those rules and draw it on top of here. So what are the other components here? Well, we have a parallel component to the force of gravity. So I'm actually going to draw it right here next to the force of friction, and I am going to call that force of gravity parallel, like that. And then one more force here, and that is going to be the force of gravity perpendicular. And that one should go from here down to here. And I'll call this one the force of gravity perpendicular there. So again, you would not actually want to add those two onto your drawing if this was the exam we take in class or the actual AP exam. So here is an important thing to realize, that this angle right here always works out to be the same as this angle right here. So this is also 20 degrees. You don't need to show that. It's okay if you go ahead and label it. All right, and we're going to need this drawing in order to do this next part here, because the next part says calculate the normal force of the plane on the box. If you need to draw anything additional there, that's what we were just saying. Don't add it to your figure here. I know I did it. But anyway, let's think about it. The normal force here has got to be equal to the force of gravity perpendicular. And the way we want to start that off is by saying that the sum of the forces in the y direction is equal to mass times acceleration in the y direction. We know that's 0. So we know that the sum of the forces in the y direction is equal to 0. Now let's add some more stuff. What are in the y direction? We have normal up, and we have the force of gravity perpendicular down. So the normal force must be equal to the force of gravity perpendicular. This is always true for every single inclined plane problem, no matter what's going on. How do we find the force of gravity perpendicular? Well, you can see here it's the adjacent side to the angle, so we're going to use the cosine function there. So let's write that in there. So the normal force is equal to the force of gravity perpendicular, which is mg for the force of gravity times the cosine of the angle. Let's go ahead and plug some numbers in here. They said that the box was 50 kilograms, we know gravity is 10 meters per second squared, and the angle they said is 20 degrees. So the normal force will equal, when you multiply all of those things out, about 470 newtons in that case there. So normal force always equal to force of gravity perpendicular. Calculate the component of the force of gravity acting on the box that is parallel to the plane. So we're going to do a similar thing right there. This time we want to find this component there. You can see here it's the opposite side of the triangle, so we're going to use the sine function in this case. So the force of gravity parallel is equal to the force of gravity times the sine of the angle. So let's go ahead and plug in there. Mass times gravity times sine of the angle, and put in some numbers. So mass is 50, gravity is 10, the angle is 20, and so in that case there, we'd get about 171 newtons there. Next problem here is D. They say calculate the force of friction between the plane and the box. So in this case, we know that the force of friction is always equal to mu times normal force. Well, hey, they gave us mu. They said that mu was 0.3. And we already found the normal force in a previous problem. It's 470 newtons. So if we simply multiply those two together, then we can get our force of friction, which is about 141 newtons there. Last part here, calculate the force applied by the person on the box. So now we got to go and look at the parallel direction, or the x direction, whatever you want to call it. I'll call it parallel here. So the force of sum of the forces in the parallel direction is equal to mass times the acceleration in the parallel direction. Well, they said, remember, it's a constant speed, so that's equal to 0. So we can say that the sum of the forces in the parallel direction is equal to 0. What are the forces in the parallel direction? Well, we have the force applied up the plane, we have the force of gravity parallel down the plane, and we have the force of friction down the plane. So if I move these two over to the other side, I can say that the force applied must equal the force of gravity parallel plus the force of friction. We already solved for both of these, so we can just simply plug in those numbers. So the force of gravity parallel we found earlier was 171 newtons, and the force of friction we found earlier was 141 newtons. So when we add all of those together, then we should get 312 newtons there. The last part, F, we'll skip because we don't know how to do work yet.